So, good afternoon, my dear students. In the previous video, I was explaining you about how to calculate or how to determine the centroid for plane geometric sections. So, in this session or in this class, I'm going to explain you how to determine the coordinates of centroid for any plane section. Let us consider a T section here, which just looks like an alphabet T. So, I'm just calling this one as a T section. Now, the dimensions of the T section are the width of the flange is given as 100 millimeter, this one 100 millimeter, and the thickness of the same thing again, it is given as 20 millimeter. Next we have the web. This part is called as web, which is taken as 80 millimeter. Up to here it is 80 millimeter, and the thickness of this one is 20 millimeter. So generally in the question they don't give us the x-axis and y-axis. Here I am just considering it in the first quadrant. So generally this one is a symmetric section. When I draw a line which is passing through the center, it will be symmetric about the y-axis. But I am considering it in the first quadrant by considering the x-axis, reference x-axis exactly to the bottom, and reference y-axis towards the left side of the section. Now, how to solve this problem? How to determine the coordinates of centroid for this given rectangle? The first thing is just let me assume that there is a point capital C whose coordinates are x bar and y bar, where x bar is the distance from the reference y-axis and y bar is the distance from reference x-axis. Just you have to remember this one, the most important thing. X bar is the distance from reference y-axis, from this point to reference y-axis. Whatever the distance you measure here, it is taken as x bar, and from the reference x-axis, from this axis to this particular point, the distance measured is taken as y bar. Okay, now in the next step, what I'm going to do here is just I'm going to divide the given section. How to divide the given section? Just as you can see clearly here, it just looks like a T section. When I draw a line over here like this, it can be divided into two rectangles. I'm just considering this, the bottom one as the first rectangle and the top one as the second rectangle. So this is the first rectangle and this one is the second rectangle. Now let us assume in the second step, let us assume that for the first rectangle there is a center C1, x1 comma y1, and for the second rectangle again there is a point C2 whose coordinates are x2 and y2. Now what are these x1 y1 and x2 y2? x1 y1 and x2 y2 are the coordinates of centroid for the first as well as second rectangles, or the divided rectangles. Okay, now let us assume that C1 x1 y1 and C2 x2 y2, these are nothing but the coordinates of centroid for the given rectangles. And also I'm assuming that A1 is the area of the first rectangle and A2 is the area of the second rectangle. Now for my convenience, I'm drawing the rectangles once again. The first rectangle, the width of the first rectangle is 20 millimeter, and the depth of the first rectangle, it is 80 millimeter. Now A1 will be equal to 20 multiplied by 80 millimeter square. In the similar manner, we have the second rectangle. The width of the second rectangle is 100 millimeter, and the depth of the second rectangle, it is taken as 20 millimeter. Now A2 is the area of the second rectangle, that can be 100 multiplied by 20 millimeter square. Now the next step is to find C1 x1 y1 and C2 x2 y2. What are these C1 x1 y1 and C2 x2 y2? As I have already discussed, C1 x1 y1 and C2 x2 y2 are the coordinates of centroid for the divided rectangles. So I'm just explaining you again. So if I consider the reference x-axis and y-axis, and if a rectangle, right, for example I'm just considering the first rectangle here, so it has got some coordinates C1 whose coordinates are x1 comma y1, where x1 refers to the distance from the reference y-axis, so this is x1, and y1 refers to the distance from the reference x-axis. Okay, now I have drawn a very neat sketch of individual rectangles. The first rectangle, the coordinates of its centroid are c1, x1 and y1. We know that it has got a width of 20 millimeter and a depth of 80 millimeter. And I told you that when we draw a line which is passing through c1 and c2, right, it will be symmetric. That means it is equidistant from the reference y-axis. So obviously, whatever the web you are seeing over here, it will be located exactly in the middle of this particular flange. So 100 millimeter, it is exactly divided into half, so we'll be getting around 50 millimeter. So x1 will be equal to 50 millimeter. And what about y1? Y1 will be exactly in the center, that is half of 80 millimeter is 40. So I'm writing down the coordinates c1, x1, comma y1 will be equal to 50, comma 40. Units are millimeters. And we have already determined the area of this one. A1 will be equal to 20 multiplied by 80, which is equal to 1600 millimeter square. Okay. Now coming back to the second rectangle here, as you know that the width of the rectangle is 100 millimeter and the depth of the rectangle is given as 20 millimeter. Now x2 refers to the distance from the reference y-axis, which will be half of 100 millimeter. X2 will be equal to 100 divided by 2, that is equal to 50 millimeter. And y2 will be the total distance from reference x-axis up to this point. But we know that the depth of the first rectangle is 80 millimeter, which is already given to us, and half of this one, I mean to say, this will be 20 divided by 2, remaining 20 divided by 2. So the point C2 is located exactly at distance of 80 millimeter plus half of 20. So it will be equal to 80 plus 20 divided by 2, which is equal to 90 millimeter. Now C2, x2, comma y2 will be equal to 50, comma 90 millimeters. And we already know the area A2, which is equal to 2000 millimeter square. So in the previous class, I was explaining you about the formula to calculate the coordinates of centroid for plane figures. So it is capital C x bar y bar is equal to sigma ai xi by sigma ai and sigma ai yi divided by sigma ai. So I'm expanding the formula. X bar is equal to a1 x1 plus a2 x2 by a1 plus a2, and y bar will be equal to a1 y1 plus a2 y2 by a1 plus a2. So we already know the coordinates. X1 is 50 millimeter and x2 is also equal to 50 millimeter. Y1 is 40 millimeter and y2 is equal to 90 millimeter. Already we have the areas A1 and A2. A1 will be equal to 1600 and A2 is equal to 2000. So I'm just substituting all these values. A1, which is equal to 1600 multiplied by x1 is 50 plus A2 is 2000 multiplied by x2, which is again equal to 50 divided by 1600 plus 2000. As it is symmetric, so 50 is taken outside, so obviously we'll be getting the value of x bar, which is equal to 50 millimeter. And coming back to y bar here, y bar a1, which is equal to 1600 multiplied by y1. Y1 is 40 millimeter plus a2 is 2000 multiplied by y2. Y2 is 90 millimeter divided by 1600 plus 2000. So after calculating, we'll get the answer as 67.77 millimeter. Now for the given T section, we have capital C x bar comma y bar, which is equal to 50 millimeter and 67.77 millimeter. The units are most important. If you don't place the units, your entire solution will be wrong. So For the given section, whatever the section we have considered here, right, the coordinates of centroid capital C, x bar and y bar we have calculated, and the answer is 50 millimeter and 67.77 millimeters. Thank you.